stops when I get confused. Do y'all see into this one? I think multiplying by 3 here messed something up. H2, F2. H2 needs to go away. H2 plus F2. Okay, I didn't change it, so negative 573. So I just rewrote that equation. I've got this, I've got 6F2. So if I multiply it through here by 2, then I can get rid of that. But I still think I'm off here somehow. All right. Get rid of the 3. If I'm going to end up with 6F2, I can multiply this by 4. Since I need 4 HF, I'll multiply this by 2. $573 times 2. That gives me 4F2 with these two. So now I can multiply this by 2. Yes. 2 times that becomes 4, 2, 680 times 2. I think that does it. So the C's cancel. This doesn't cancel with anything on that side. But that's what I needed. There's no F2s over there, so these add up to 6 F2s. That's a 4. So that's these. I've got 2H2, cancels with 2H2. 2 F4 plus 4 HF. I think that does it. Did I switch any of these backwards? Did I do that right? I swapped that one and I changed the sign. And then the other ones I did not. All right. So this should just add up. 52.3 plus 1360 plus 1146. And I get, my calculator says 2558.3, and it's negative. That's kilojoules. Nothing after the decimal, nothing after the decimal. So I won't report that. So that's at 2558. I'm afraid to look. Was that a red one?
Yeah. Yeah.
I'll be gutsy and look to see if I got it right. 565. All right, the red. They got 249. kilojoules. Did I write something down wrong? Which one did I do?
You put POP 73 instead of POP 37. That was good.
Ah, good. And then that would multiply up different. If you did that on the test, it would only be a little bit off. If you transpose those two numbers and I look through all your math, I might not even take any points off because you did everything correct. It's a simple mistake. I do that because I make those mistakes, so it's just me being honest. All right, so I'm definitely going to put at least one like that on the test. I did put one of those on your practice test. And I'm going to skip formation enthalpy for this test, even though it's very simple. The fact that I got confused on it the other day, I was over-explaining, as I like to do. The other one's like this. Another one from this is the bond enthalpies. I put one on your practice test. Let me give you this. Just because I slapped it together this morning, I didn't give you structures. Where is it? There's one like that. This one, this is on your practice test. I just didn't draw it on there. I'll give you the structures so you can see where the bonds are for this type of question. So what I would give you on the test is this. CH4 is this. And then carbon dioxide is a double bond. And then CO2 looks like this. And H2O. So that shows you where the bonds are and what types of bonds there are. But this is just a matter of adding up the enthalpies. I'll give you this chart on the test. I printed that one out. I didn't bring mine. You guys have that chart? This chart. Anybody have that chart? It's essentially this equation though. So bonds broken, the way you count this up is there's 4 C to H bonds plus O. Is that balanced? I guess I did balance it. 4 hydrogens, 1 carbon, 4 oxygens. Okay, it is balanced. So there's a 1 here, there's a 2 here, and there's a 2 here. So those matter. So 4 of those plus 2 times. So there's basically a 1 here. So 1, 4 bonds. There's a 2 here. There's only 1 of those.
Do double bonds just count as one bond then?
There's literally a double bond on the chart. You'll look up and you'll find what is an O to O double bond.
Oh, I see, okay.
There's essentially a 1 here, and there's 2 of those. So I'll say 1, and there's 2 O double bond C. That there. Plus, there's a 2 here, and there's 2 of those. H to O single bond. I did that because I know y'all can't see past the screen there. So now you just count it up. Look on that chart, what is a C to H single bond?
413.
413. 4, 1. To this real quick. These are the bonds that are breaking. We've got 2, 1. What is the O to O double bond? 495. Minus. And now we add up all the bonds that are forming. O to C double bond.
799.
Plus 2 times 2. And H to O single bond.
463.
63.
463.
63. All right. You guys see where these numbers are coming from? These integers? The rest is plug and chug. $495 times 2 minus 2 times 799. $15.98 plus $18.52. All right. 2642 minus 3450. I ended up with negative 8. Nothing after the decimal. That would have been 3 significant figures. That one would be 3. That one would be 3. That one would be 3. But since it's addition, that's fine. So I think that's it. That chart is in kilojoules. Look at the top of the chart. kilojoules per mole. So negative 808 for that one. What have I yet to have done? These, I won't have you write the net equations, but if I gave you these as reactants, like this, these are acid-base, aka neutralization reactions. HBr, calcium hydroxide. So one of the things we're going to make is H plus OH. So we are going to make water. The other thing we're going to make is calcium bromide. It's going to need a 2. And to balance it, I think that does it. 2 BRs, 2 BRs, 2 H's. I got those 2 H's together with those 2 OH's. That. Now, 2 H's. I do make 2 of those. 2 of those, 2 of those. So I've got 2 H's, 2 BRs. I've got 1 Ca, 2 plus, 2 OH's, Ca, 2 plus, H, two of those. All right. Those. 2 of those. 2 BRs. And let's see. Okay. So that's balanced. And you would just put liquid here. And calcium bromide is soluble. And these you would put aqueous on. We already have them there. So acid-base neutralizations. Let's do the next one. Copper hydroxide. That's copper 2 hydroxide, HClO4. Okay, we're going to use this hydrogen H plus with OH to make water. We're going to make, we're going to need 2 of them, 2 there. All right, that takes care of the OHs and the H's. So we've got chlorate and Cu. ClO4 It's copper 2 hydroxide. So Cu. And then this is going to split into H plus and H plus. Cl4. Again, I'll give you the polyatomic ions. Two of those, and then I get my 2 waters here, and then this is my CuClO4 Is it balanced? I think that's balanced. And then aqueous, all chlorides are soluble, and this will be L for liquid. You guys okay with that? Neutralization reaction. You think you could do this last one? Aluminum hydroxide. Aqueous. Nitric acid. I already know we're going to need a 3 there. So I've got my 3 H pluses and my 3 OHs. Give me 3 H2Os. That's aqueous. All nitrates are soluble, so aluminum nitrate is soluble. Aqueous liquid. Acid-base reaction. The things that I need to make a Part B for your practice test are just a small number of things that I need to give you. They didn't do it on test 1, so that is go remember this. Let me go 5.4.
Yeah, I don't need one. Well,
I think I assigned these as part of test 1, but I didn't put it in the test. So let's see what I put on here. Maybe I didn't. Okay. 5.43, probably 5.44. What I want you to be able to solve. Where is that? Five point four three, 5.44. Just write this. 2CH3OH. Two CH4 and 2O2. Is that what it says? 2CH4, 2O2. All right, and delta H is 252.8. Kilojoules. All right. So this is where I've said this to you before. For this reaction, there's three relationships. There's two, or no, do it like this. 252.8 kilojoules for 2 moles. There's one of the relationships. Another one is 252.8 kilojoules to 2 moles. It's just one O2 to 2 moles of and then there's one more relationship. 1 mole of O2. And you'll use one of those relationships to calculate something. All right. First of all, is it exothermic or endothermic? This is positive, that means it gained heat. So it's endothermic. Okay. The amount of heat when there's 24 grams of the methanol. 24.0 grams of methanol. 4.0. So first we need there's 1 carbon, there's 4 hydrogens there, there's 1 oxygen, so we've got 12.01 plus 4.04 plus 16. Is that right? So we have that relationship. Does that make sense? All right, 24 grams. .05 grams to 1 mole. And then what's left here is 2 moles to this. And that'll end on kilojoules. How much heat is transferred? Grams cancel, moles cancel, we end in kilojoules. 4 times 252.8 divided by 32.05 and divided by 2. So I end up with, my calculator says three significant figures, 4, 4. That's exact. So we need 3. That's how much heat you'll get if you react 24 grams. And there's no excess there. All right, let's do C. Slightly different way to ask this. So if the enthalpy change is 82.1, how many grams of methane gas? Okay. This is the methane. That's the methane gas. That's methanol. I won't make you know that on the test. I would say CH4. How many grams of CH4 is the way I would say that on the test. All right, so. So, 82.1 kilojoules. And then 252.8 kilojoules to 2 moles of methane. That's one of those relationships I wrote right at the beginning, but I had it flipped over. So I've got it flipped this time. So kilojoules cancel. We're in moles here, and then how many grams of methane? All right, we need grams per mole for methane. CH4, so 16.5 grams per mole. 1 mole CH4. How many grams of methane? So there's that relationship involving this. This is the grams per mole, and this is the arbitrary number that's given to you as a problem. Divided by 252.8. Calculator says three significant figures, 4, 4, so we're going to keep 3, so it's you guys follow that? Anything else you want to review? Okay to stop here. So problems like that, I don't have in that practice test. And I don't even think I gave you practice problems in the chapter. So that's what I'm giving you here. Look at that, practice what we just did, and then the red one you should have answers to in the back of the book. I'll finish that before I go home today, the rest of the practice test. It's that, and I think acid base is not on that practice test that I slapped together this morning. Any questions? Anybody want to meet after lab? You're welcome to stick around and ask questions after lab. We won't have lab Thursday, so you'll just come and take the test and forget about chemistry. You guys okay? I still feel weak. I think I'm dehydrated.